And so it says draw, so I want you to actually take the time, extra 5 seconds to draw. So here's a suitcase, right? When you're on a trip, you take a suitcase, and they're telling you that this measures 24, the length, the width measures 18, and they're asking you for this, the diagonal. Well, it's a right angle triangle, right? It's a suitcase. Most suitcases are rectangular. So, right angle triangle. These are two of the legs, call them A and B, and obviously this is the hypotenuse C. So, just a matter of plugging it in. We're going to go 18 squared plus 24 squared equals C squared, and C is what we're trying to find, so you know we're going to have to take the square root of both sides. So 18 squared is 324. You can just put the whole thing in your calculator if you can, or you can do it separately. 576 equals C squared. And if you add them up, you get 900. So C squared equals 900. You take the square root of both sides, and we're interested in the plus 30. And that's the diagonal. And this goes the same for TV, right? When they talk about 56-inch TV, 70-inch TV, they're actually talking about the diagonal, right? That's here. Next one. To get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south. So imagine you're here. So north, south, east, west. So you're going to go south 34 meters. So we know this is 34. And you're going to walk east 41. Right, so we know, what is it? Meters, yeah. And then just to the nearest meters, how many meters would be saved if it were possible to walk around the pond? So apparently there's a pond here. Okay. Pond, water, and if you could cross the pond or walk on water, what would be that distance? And again, this is C, right? So we're looking for the hypotenuse, and let's call this A and B. A squared plus B squared equals C squared, so we got 34 squared plus 41 squared equals C squared. 1156 plus 41 to the second power, which is 1681. Add them both up, we get 2,837. Take the square root of both sides, and we get, what is it? What did they say? To the nearest whole meter. So the answer is 53.26. Etc. So to the whole nearest whole meter, it'd be 53 meters if you could walk across water. Next one, two joggers. Okay, so again, just write north, south, east, west in case you forgot. So we have two joggers. They run north, so they're going north 8 miles. And then they walk. Let me start here at the bottom. Okay, so they go north 8 miles, and then they go west 5. Now, if they were to return and take the shortcut, which would be right, the shortest distance between the 2 points, which would be this one. This is also what would be that distance. So we're looking for C again, and call this A and B. So I think the important thing here is for you to have a visual, right? Oops. 8 squared equals C squared. We get 25 plus 64 equals C squared. We get 89 equals C squared. Take the square root of both sides, and C equals to the nearest tenth of a mile. Okay, so I'm just going to follow what they say. Usually we do it to the hundredths, right? So, but they said tenth, so we're going to stick to 9.4. This one, you're on the ground, so let's see, this is the ground, and there's you. And you're looking up on a window in the building, so this is what you're looking at. And there's a building. And here's a window. Okay, the window's 30 meters above the ground. Okay, so actually maybe I should put you back here. Okay, there's you, and you're looking. And the window's 30 meters above the ground, which is this. So this is 30. You're standing 20 meters. Let me just a little bit more to scale. You're standing 20 meters, so let's put you over here. You're looking over the window. This is 20. How far above where you're standing is the window? So this is, again, you're looking for C. So A squared plus B squared equals C squared. Let's call this A and let's call this B. It doesn't matter, but 20 squared plus 30 squared equals C squared. We get 400 plus 900 equals C squared. 1300 equals C squared, square root of both, and then we want the positive, so square root of 1300 equals 36.05, 06, rounded to near something. Okay, so now do these triangles, to these side measurements, form a right triangle. So let's take the first one. So, and obviously the first thing you should do is label who is who, and we are going to get the longest side to be the hypotenuse, or C, and the other two are A and B. Okay, so the first one, we're going to go 6 squared. If that's true, if those represent the side measurements of a right angle triangle, then this equation should be true. So we get 36 plus 64 equals 100. 100 equals 100. So because that's true, then these three represent the length of a right angle triangle. So this one is a yes. So the next one, so it's 10 squared, sorry. Let's call this A, let's call it B, and C is always the longest side. So 10 squared plus 24 squared equals 26 squared. That's 100. 24 to the second power is 576. 26 to the second power is 676, and they're going to be equal to each other. So these three side lengths also represents side length of a right angle triangle. Just make some room here. Next one again, A, B, and then the longest side C. So 9 squared plus 12 squared equals 18 squared. This is 81 plus 144 equals 324, and this one is definitely not going to be equal to each other because we get 225, saying that it's equal to 324, and it's not. So these three are not the side lengths of a right angle triangle. Last one, 16 squared, sorry, A, B, and C, plus 30 squared equals 34 squared. So 16 squared is 256 plus 900 equals 34 squared. That's 1,156, and in this case they are equal to each other. So these three also represent the side length of a right angle triangle. Alright, so again, just very repetitive first page. Let's call this A, let's call this B, and X is C. So 2.3 to the second power plus 5 to the second power is, we're going to find the length of the hypotenuse, C squared. 2.3 to the second power is 5.29 plus 25 equals C squared. That's 30.29 equals C squared. Take the square root of both sides, and that's going to give me A, B, and then C. 14.5 to the second power plus 7.5 to the second power equals C squared. So we get 210.25 plus 7.5 to the second power, which is 56.25, equals C squared. Let's add both of them. And we get 266.5 equals C squared. So we got to take the square root of both sides. And take the square root of that. And we get, rounded to nearest hundreds, 16.32. Okay, rounded. Finally, two questions where we have to find the legs. So we have, call that A, let's call that B, let's call that C. So this time we don't we're not looking for the hypotenuse. So a squared plus b squared equals c squared. A is 11.9 to the second power. B is what I'm trying to find, the hypotenuse I have. Okay. So we're going to go 141.61 plus b squared equals 17 squared, which is 289. So now we're going to isolate b, right? So remember, our answer has to look like this. B equals something. So let's subtract this guy from here and subtract it from the other side as well. We're going to have b squared equals 147.39. Take the square root both sides, and then we end up getting 12.14 approx, rounded to nearest hundredths. Okay, so there's an extra step here where we have to, before you take the square root of both sides, you have to get rid of this constant here to isolate b. Same thing on this side. All right, so we're looking for one of the legs. Let's just make it, change it up, make that b, make that a, make that c. So a 126 squared plus b squared equals 136.5 to the second power. We get 15,876 plus b squared equals 136.5 squared, which is 18,632.25, and we're going to subtract that 15,876 from both sides. We end up getting 2,000, so b squared equals 2,056.25 square root, we're going to get some ugly number, and that number is 50, actually not bad, b is equal 52.5, actually pretty number. What do we have here? Okay, so there's a house, so let's draw a house. House. Okay. So there's a 39-foot ladder be placed so that the top of the ladder will reach the point of the house 36 feet from the top. So they're saying if this is 36, right? So I'll put 36, and this ladder here is 39, right? Measure this ladder here. And this ladder measures 39. So what is this distance here? That's what we're looking for. Right? How far should the base of the ladder be from the base of the house? So here's your right angle triangle. Let's call this guy A, let's call this guy B, and let's call this guy C. So we're looking for one of the legs, and we have 36 squared plus b squared equals 39 squared. We're going to get 1,296 plus b squared equals 39 to the second power, which is 1,521. We're going to subtract 1296 from both sides. That goes away. B is finally isolated, and we get 225. It's going to be a pretty number. Square root, and the answer is going to be 15. Oh, sorry. And B is 15. So it should be 15. What is that? Feet. The base of the house to the base of the ladder should be 15 feet apart. There's another problem here. So against a building, oh, thank God, easier to draw. Here's a building. Door, windows, and 18-foot ladder. So there's a ladder already leaning against the wall. So we know that the ladder is 18. So there's my hypotenuse. The base of the ladder is 9 feet from the base of the building on the level ground. So this right here is 9. So how far up on the building are we? So we need to find this guy here. This is our unknown. So let's go. That's the hypotenuse. This is B, and we need to find A. So A is I don't know. B is 9, and then C is 18. So A squared equals plus 81 equals 18 to the second power, which is 324. We're going to subtract 81 from both sides. And we get a squared. A squared is 243. Take the square root of that. And a equals 15.59 approx. Okay, down to the nearest hundred, so that's the height. Alright. Pythagorean triples, list 4. So go through your notes. I just list 4 because, what do you call it's what we did the other day. It's just for you to look at. So again, Pythagorean triple are a set of length of a the three sets, the three lengths of a Pythagorean triangle, right? So the popular ones are the ones that are easy to memorize. One of them is obviously 3, 4, 5. So it's nice because sometimes you have a problem. I mean, and they say, hey, this measures 3, this measures 4. Use the Pythagorean theorem and find the hypotenuse in this case. Well, you know it's 5 because that's one of the triples. So 3, 4, and 5 is one. Okay, and 5, 12, and 13. Somebody mentioned that in class that they remembered that one. Okay, 6, 8, and 10 is another one. Again, and if you multiply these by 2, 3, 4, 5, look, you get 6, 8, 10, which means that I can also use 9, 12, and 15, right? Take this, multiply by 3, you get 9, 12, 15, 5, 12, and 13, and if I multiply all the sides by 2, I get 10, 24, 26, and then I can grow from there, right? So just knowing these two, for example, I can come up with this, this, and this by multiplying all the same size by the same factor. Okay. All right, so that's that. Now some questions on spheres, and this one is a sphere, so volume is 4/3 pi r cubed. We need the radius, and they give us the radius, which is 9, so we have 4/3 pi 3 to the third power, 4/3 pi times 27. We can simplify, and we're going to get 36 pi. So it depends on the answer. So you can leave it in terms of pi. Or they actually say, hey, I want you to give me the numerical value. It's 113.1. Rounded to the nearest hundreds. This one's 27. So again, repeat. Again, so volume is super easy, right? Because all you got to do is plug it in. So V equals 4/3 pi 27 to the third power. So let's get that done there. So this, right, if you multiply the 4/3 and 27 to the third power, you get 2,622, 2,600, that's 26,244 pi centimeters cubed, or multiply that by pi, and we get 82,447.96 centimeters cubed. This one, the only difference is that you notice that this is the diameter, so obviously the radius is half that, so it's 9, so that's what you should be using. And let me just, wasn't there a problem with 9? So 4/3 times pi times 9 to the third power, and that's going to, what do you call, simplify nicely for us for 4/3 times, it's going to be 972 pi inches cubed, or 3,053.63 inches cubed. Okay, round it. Let me go back. I think I forgot to divide by 2 on this one. So going back to this problem over here. Okay, I made a mistake. What is the mistake I made? I found the volume for a full sphere, right? If that was a full sphere, but this is not a full sphere, so I had to divide this fella by 2. So 82,447.96, which I rounded off, unfortunately, but it's okay. Divided by 2, 41,223.98. centimeters cubed. So that's the actual approximate volume for this sphere, which is only half a sphere. So bottom one, let me redeem myself. So the radius is not 42, it's 21. So the radius is 21. So again, 4/3 pi r cubed, v equals 4/3 pi times 21 to the third power. So we plug that in. 4/3 times 21 to the third power. That's going to give us 12,348 pi. Okay, and then over 2, right? So if I divide that by 2 and you leave it in terms of pi, your answer is actually why can't I say numbers? 6,174 pi. So if it's in terms of pi, that's the answer. And if they want the actual value, multiply those out, so times pi, and you're going to get 19,396.13 centimeters. Okay, so just remember that if it's half a sphere, you just divide it by 2. Find the radius. So we have now a sphere with a radius. So volume. Find the radius. I need to find the radius. Volume equals 4/3 pi r cubed, and it's telling us that the volume. So let me write the volume. 3,052.08. That's the volume. 4/3 pi r to the third. So I want that equation to look like this because I want to find the radius. So I have to get rid of 4/3 pi on this side. So I'm going to divide by 4/3 pi, and I'm going to divide this side by 4/3 pi. That's going to go away. We're going to be left with r to the third power and something. 3,052 point, yikes, 3,052.08 over 4/3 pi, and if you do that, you get 728.63 ... and then we're going to find the cube root of that. So we're going to go, let's see if I remember to do this. Yeah. And we're going to get rounded 9, because you get 8.998, so the radius is 9. Okay, so just remember that, sorry, I forgot to write a 3 here. We need to write a 3 because we're finding the cube root of both sides. Cones. Cone cylinder is very, very similar. So it's just 1/3 pi r squared h. Yeah. 1/3 pi, radius is 5 squared, and the height is 18. So I simplify that 6. So we end up having 25 times 6, which is 150. So 150 pi feet cubed, or 471.24 feet cubed. 1/3 pi r squared h, volume equals 1/3 pi. The radius, please be careful, is 2. So it's 2 to the second power times the height, which is 12. Okay, so we can actually simplify the 3 and the 4, and the 12 makes it 4. So 2 squared is 4 times 4 is 16. So I can actually leave it in terms of pi and say that 16 pi meters cubed, or 16 times pi, oops, okay, 50.27 rounded meters cubed. Okay. Find the height. Now we have the same thing, but we want to find the height. So volume is given to us. Right, so volume, we want the height. So volume is, what's the volume? 1,256 equals 1/3 pi. The radius is, they tell us the diameter is 20, so the radius is 10, so 10 to the second power h. We're going to solve for h, so we're going to have to make that equation look like h equals something. So we're going to isolate it. Where we go? H. So 1,256 equals 10 to the second power is 100. So, and if you multiply that by 1/3, you get 100 over 3 pi h. So let's simplify things. So now we're going to divide both sides by 100 over 3 pi, and then same thing here, 100 over 3 pi. So 100 over 3 pi and 100 over 3 pi simplify, and we get h equals, and we're almost there. So 1256 divided by 100 over 3 pi gives us 11.993, and if we're rounding to the nearest hundred, it's actually 11.99. Do not take the square root of anything because h has an exponent of 1, so we're good. Here, find the radius of a cone. Okay, so again, this time we're looking for the radius. So volume is 175. 1/3 pi, radius is what I'm looking for, so I'm leaving that alone, and the height is 21. Okay. So, you're going to put that in your calculator, of course, but I'm going to simplify the 3 and 21, which gives me 7. So I get 7 pi r squared. Divide by 7 pi, and divide the other side by 7 pi, so I can isolate the r to the second power. 7 pi simplifies to 1, and then on the other side, 175 divided by 7 pi. 175 divided by pi. Rounded, we get 7.96. So the radius is 7.9. So the radius square is 7.96. Take the square root, and we get that r is 2.82. Alright, cylinder. Ugh. Yikes. Alright, so cylinder is almost the same thing, except that's not 1/3, so it's just pi r squared h. Volume equals, radius is 7, so 7 squared times 13. So this is pretty straightforward. Right, so 49 times 13. So 637 pi inches cubed, or 2001. 2001.19 inches cubed. Same thing here, except that the radius here is 11, right? That's the diameter, so we want the radius, so it's 11 to the second power times height, which is 10. So 121 times 10 is 1,210 pi feet cubed, or 3,801.33 approx feet cubed. We need the height in this one, so the problem is the height. So again, volume equals pi r squared. So we're solving for h. The volume is 800. The radius is 4.5 because that's the diameter, so be careful. And we're solving for h. So 4.5 to the second power is 20.25. So 800 equals 20.25 pi h, right? We want to isolate h because that's what I'm looking for. Let's divide both sides by 20.25 pi. So 800 divided by 20.25 pi is 12.56, 58 approx. This one we want the radius, so what's the volume that they tell us? The volume is 9,000, so pi r we're going to leave alone, and the h is 12. So let's, we want to find r, so we got to get rid of the pi and the 12, so let's divide both sides by 12 pi. Pi and pi goes away, 12 and 12 also goes away, simplifies to 1, so on the other side we're going to say 9,000 divided by 12 pi equals 230. So r squared, and I'm going to leave that number, round it. I'll round it here, but in the calculator I'm going to leave it. And now I'm going to take the square root of that big number. And we get that r is 15.45. Alright, so a little bit of everything here. So let's do the cone, the popcorn in the cone. So volume equals 1/3 pi r squared h. Volume equals 1/3 pi. What's the radius? The radius is glasses. The radius is 6, right? Because that's the diameter. So we want 6, and let's go ahead and the radius is 4 over here. So 6 to the second power times height, which is 19. So volume is, so let me take care of the 1/3, 6 squared, and 19. So 19 times 36 times 1/3 is 1228 pi. And I'm going to multiply that by 228 times 20 times pi. I'm going to get, so the volume here is 716.28 approx. Okay, centimeters cubed. The volume of the second one, which is a cylinder, what's the radius is 4, so 4 squared times the height, which is 15. So 16 times 15 equals 690 pi, or 2,000 each. Really? $2,000, 690 times pi, or 2,167.7. Okay, centimeters cubed. I mean, it's not even a constant. I was going to find the unit rate, but 675 and this is 629, so obviously this is the much better deal. You know what, just to be, so I complete the question, what I'm going to do is I'm going to find the unit rate. So the unit rate here is $6.75, and you get 716.28. Centimeters cube of popcorn. So if you want to find the unit rate, so 1 centimeter cube of popcorn gives you how much? So let's just divide 6.75 divided by 716.28. You can get that every centimeter cube of popcorn is about 9 cents. Whereas this, it's $6.25. And you get 2,167.7 centimeter cubes of popcorn, and 1 centimeter cube of popcorn will cost you 6.25 divided by 2,167.7. Wow, very, very cheap. 0.00, I'll round it, 3. So not even a penny. Okay, so you're much better off buying that. Alright, composite is just 2 shapes in one, so it just means double the work. That's all it is. So let's do the cone. Now this cylinder here. The cone is 1/3 pi r squared h. The radius of the cone is 9, which is the same radius as the cylinder, so 9 squared, and the height of the cone is 12. Just plug that in, so we get 81, which is 9 squared, times 12, and then times 1/3 or divided by 3, we get 324 pi. I'm going to leave it in terms of pi, and I'll show you why in a second. And then the cylinder is pi, the radius is 9 again, so 9 squared, and the height's 15. So if you leave it in terms of pi, it makes it a little easier. 81 plus 81 times 15, and you get that the radius, sorry, the volume of the cylinder is 1,215 pi. Now, to find the total, we add both, and it's probably easier to add it in terms of pi first. If you add that, you get 1,215 plus 324 pi gives you 1,539 pi. And then here is a step where you would, if they ask you, change that and actually multiply it out. And you get 4,834.91 centimeters cubed. So 2 answers, either in terms of pi or to the nearest hundredth. Careful here, it's not a full sphere, it's a half a sphere, so volume equals 4/3 pi r cubed. And if you want already, put it over divided by 2, because you're going to cut it in half. So if that's what you want to do, that's completely fine. And you know what? But I don't want to confuse you, so I actually left it for last. So I'm going to leave it for the way I did it in class. So 4/3 pi r cubed. So remember, the radius is 3, not 6. So I'm going to 3 squared. 3 cubed. Volume equals 4/3, and then so 27 times 4 divided by 3, we're gonna get 63 pi. So let's leave it in terms of pi for now. So that's the and then we have to divide this by 2, which I almost forgot again. We divide that by 2, we get the volume of the this is a hemisphere. This half of the sphere. Right, so we divide that by 2. It's actually 31.5 pi centimeters cubed. The cone was at the bottom. Okay, so let's do 1/3 pi r squared h. Volume equals 1/3 pi. What's the radius? Again, the radius is 3, so 3 to the 2nd power, and the height is 10. So 9 divided by 3, 3, and then you're going to get 30 pi in terms of pi. Now, remember, the final answer is this and this guy combined, so we do 30 pi plus 31.5 pi. Treat the pi as if it was a variable, right? So these are the same variables, so we get 61.5 pi centimeters cubed, or 61.5 times pi, which gives us 193.21 centimeters cubed. This is rounded to nearest. And we got 2 more. Yay. Cylinder. Hold on, do it right off the bat. The volume is pi. What's the radius? Is 7, so it's 7 squared, and the height is 20. So we get 49 times 20, and let's leave it in terms of pi. 980 pi feet cubed. The volume of a cylinder is 4/3 pi r cubed. Volume equals 4/3 pi, and what's the radius? 7, so 7 to the 3rd power. So 7 times I'm actually going to leave that in fraction format. I don't like when they, okay, so 7 raised to the 3rd power times 4. So we get 1,372 over 3 pi. Let's just leave it for that. Now, the total, right, we got to add these two totals and change colors. 980 pi plus, can I switch that to a mixed number? 1,300, sorry, I'll do that right now. Over 3 and it becomes 457 1/3 pi, which makes it a little easier to add, right? So let's add that. So we get 980 plus 457. So whole number wise is 1,437 1/3 pi. That's the answer in terms of pi feet cubed. But if you want to multiply that, so we're going to go 1,437 1/3 times pi, and the numerical value is going to be 4,515.52 feet cubed. Last question for this Saturday morning. Let's do the cylinder again. Change colors. Cylinder. Pi squared h. Right, then I change colors. Radius is 2. So to the second power, the height is 4. So this is super easy. 2 squared is 4 times 4 is 16. So 16 pi. Let's leave it at that. There's no units. So that's right, units cubed. The cone. 1/3 pi r squared h. 1/3 pi. Again, the radius is 2, so 2 to the second power. And the height is 5. So we have to leave this as 1/3. So we get 2 to the second power is 4. 4 times 5 is 20. And that's going to leave it as 20 over 3 pi. Now the total here, we have combined both of these, right? So one is 16 pi. The other one I'm going to change the mixed number. So 3 goes into 26 times, and so it's 6 2/3 pi. So 6 2/3 pi. This makes it easy to add. 16 plus 6 is 22. And 22 2/3 pi, units cubed. Or take that and multiply. Pi, rounded to the nearest hundredth, we get 71.21. Right, so approx 71.21 units. That's it. Go outside, enjoy the day for a little bit.